Hi. In this video, we're going to be talking about indifference curves and utility functions. Now, indifference curves is something you may have already seen in economics. In economics, typically when you see it, there are two different goods, two things that you like, that you want. When I took economics, it was pizza and beer, okay, were the two things we looked at. And we looked at the trade-off between pizza and beer, okay? How much pizza are you willing to give up to get more beer? How much beer are you willing to give up to get more pizza? But we all wanted more pizza and more beer, okay? Those were both goods. We wanted more pizza and more beer. It's going to be a little bit different when we're doing it here in finance, because we're going to look at the trade-off between expected return and standard deviation. Where expected return is a good, we all want more expected return, but standard deviation is a bad, and that is an economic term there. It's not just something I made up. Standard deviation is a bad. We want less of it. So we want more expected return and less standard deviation. So let's see how these indifference curves work. And again, we're going to be looking at the notes from our that I've provided for you. And I think we're going to be on what is listed as page 5 of the notes here. So let me bring up the share of the notes. And hopefully you can see that with me here. And you'll see how these indifference curves work. On the y-axis here, we have expected return, okay, which we've talked about already. That's a statistical concept. Doesn't mean you're necessarily that you're guaranteed to get that return, but we saw how we calculated it. That's on the y-axis. And on the x-axis, we're going to be talking about standard deviation. Now, we've already said that we consider all investors to be risk averse, which means they're interested in two things and only two things. They want more expected return and less standard deviation in terms of their investments. I mean, there's other things you want out of life. You want friendships, you want love, you want, a home and all these other things. But in terms of your investments, you want more expected return and you want less standard deviation. So if we see here on this, notice you get more utility by moving northwest on this graph. If we move northwest, our utility goes up because we get more expected return and we get less standard deviation. So an indifference curve, let's take a look at one of these indifference curves. Let's take a look at U1. U1 is this particular indifference curve right there. What it means is that at every point on that curve, we are indifferent. We are equally happy, or this particular investor is equally happy. In other words, at this point right here, you have a certain amount of, let's do it this way. At this point right here, you have this amount of expected return, and you have this amount of standard deviation. Now, you would be equally happy, okay, moving down here. And the reason why is you have less expected return, okay, you don't like that, but you also have less standard deviation. So the movement along this curve is the rate at which this particular investor is willing to give up expected return if they're also getting less standard deviation. Or you could look at it as moving up this way. They're willing to take on more standard deviation because they're getting more expected return. So at every point on U1, an investor has the same amount of utility. They're equally happy, okay? They're indifferent between any 2 points there in terms of the expected returns and standard deviations. But all the points on U2 are better than all the points on U1, okay, because it gives the investor more utility. So for example, going from here to here is clearly better because now the investor gets more expected return and less standard deviation. And the investor is equally happy at every point on U2. U3 is even better than U2, okay? Although as a band, you can't beat U2, can you? But anyway, in this case, with indifference curves, U3 beats U2. And so moving up in this direction is where the investors always want to be, okay? So those are indifference curves. Now, investors always want to get on the highest possible indifference curves, right? They want investments that will give them the most amount of utility, enjoyment, happiness, satisfaction, whatever you want to call it, with their investments. So in order to be able to determine what an investor's utility curves look like, okay, we need to be able to have a utility function. This utility function there's lots of different, in economics and finance, there are many different utility functions that have come up with. We're going to take a look at a very simple one. Okay, it's a quadratic utility function, and it has all the properties that we need. It's not as complex as some, but it will do just fine. Okay, but I don't want you thinking that this is the utility function. It's not. There's a number of different utility functions that researchers have used. But this particular utility function, okay, is going to work this way. Okay, it's going to say that the level of utility that an investor gets is going to be equal to the expected return on that investment minus 1/2 times A, I'll define what A is in a second, times standard deviation of that investment squared. Now, I know standard deviation squared is variance, but we're going to be talking about it in terms of standard deviation. So I'll call it standard deviation squared, okay? Because we'll keep talking about risk in terms of standard deviation. Now, let's talk about what A is. A is called the coefficient of risk aversion. And the coefficient of risk aversion for each investor is different. For all risk-averse investors, we're going to say that A is positive. If an investor were risk neutral, meaning they didn't care about risk one way or the other, A would be 0. If an investor was risk loving, meaning that they like more risk, then A would be negative. But we're assuming all investors are risk averse, so A is always going to be positive. Someone who is more risk averse will have a higher A. Someone who is less risk averse is going to have a lower A. So if you encounter somebody, you know somebody maybe in your family, okay, who is very risk averse, they just don't like taking risks on their investments with at all, you can go up to them and you can tell them, you know what, you've got a big A. Now, be careful because they may think you're referring to something else, okay? But you quickly assure them that you're talking about their coefficient of risk aversion, okay, when you told them this. So someone who has who is very, very risk averse has a large coefficient of risk aversion. They have a big A. Let me show you an example of that. It's right up above it here on this on the notes here. Let's suppose we have an investment that gives you a return of 12% right here, with a standard deviation of 15%. This is where you're at, okay? Now, this particular investor, this is their indifference curve. Notice it's a pretty steep indifference curve, okay? That means this person has a high A, a high coefficient of risk aversion, okay, with that. Now, what it is telling us is if you tell that investor, hey, I would like you to increase your standard deviation on your investment from 15% to 20%, they're going to say, yeah, I'm willing to do that. It's kind of like I'm willing to eat Brussels sprouts, but I'm only willing to do that if you offer me a higher expected return. The question is, how much extra expected return is this investor going to require? Well, this particular investor is going to require an additional 7% to go up from 12% expected return to a 19% expected return. Okay, so the investor is going to say, because they're indifferent, they are equally happy at this point, which is on the indifference curve, as they are on this point. So the investor will say, if you want me to increase my standard deviation from 15% to 20%, I'll do it, okay? But you better increase my expected return here from 12% up to 19%. Now, that is someone who has a high coefficient of risk aversion, a big A. Now, they're very risk averse. Now let's take a look at somebody who is also risk averse, but they're not as risk averse. Remember, risk averse means you don't like standard deviation, you want less of it, and you do like expected returns, you want more of it. Both of these investors are risk averse, okay? But this investor on the right now is going to be less risk averse. For this person to move up in standard deviation from 15% to 20%, they're only going to do it if they're offered more expected return. But for this investor, you only need to offer them an additional 2% to go up from 12% to 14% in terms of the expected return. So that will keep this investor on the same indifference curve. It's a flatter indifference curve, indicative of the fact that they have a smaller A, a lower coefficient of risk aversion. So this investor is still risk averse, but they're not as risk averse as this one, okay? Steeper indifference curve means you have a bigger A less steep indifference curve means you have a smaller A. This investor is more risk averse. They require more expected return as compensation for taking risk. This investor is risk averse. They still require expected return for taking on risk, but they don't require as much, so they would be less risk averse. So our utility function, okay, we scroll back down to that so we can see here, says that the level of utility we get is going to be equal to the expected return. But remember, utility is how much enjoyment, how much satisfaction. We say investors always want more utility, okay? That's going to be true of all investors. So clearly a higher expected return is going to give an investor more utility. Now, because of this minus sign here, and because we're assuming all investors are risk averse, which means they have a positive A, as standard deviation gets bigger, that means it's a larger number here that is subtracted from your expected return to give your utility, meaning more standard deviation will lower your utility. And lower standard deviation it gives you a higher utility, or at least it doesn't lower it by as much. But you can think of this A as being like the multiplier on the standard deviation. Okay, for any given standard deviation, if you have an A of 1, okay, then each unit of standard deviation gets subtracted from the expected return. But if your A is 2, that's doubling the effect of the standard deviation. If your A is 3, it's tripling the effect of the standard deviation. So a larger A means that for given increases in standard deviation of investment, it has a bigger impact on how much utility you get. So we're going to be using this quadratic utility function a fair amount, okay, over the next few lessons there. So you should become familiar with it. It's very, very simple, and it ends up giving us what we call, it ends up giving us nice curves in our indifference curves like we want to be able to see. Let me stop the share here. And okay, if you scroll down for the next couple of pages on your notes, and let me bring them back up for us to look at here, you will see a couple of examples that will help us be able to see how these indifference curves work with the quadratic utility function. In this particular case here, we've got one investor that happens to have an A, coefficient of risk aversion, of 0.75. And these are 3 different indifference curves, all belonging to the same investor. So what we would say is for this investor, every point on this indifference curve right there, they're equally happy with. Now, this particular point here is significant because this says when your standard deviation is 0, okay, the amount of utility you're going to be getting is equal to the expected return. This is going to be your expected return right here. It's going to be at 5%. Here's an expected return of 10%, 15%, 20%, etc. This is levels of standard deviation over here. So a risk-free investment gives an investor, this particular investor, okay, a return. A risk-free investment with a risk-free rate of return of 5% gives this particular investor a level utility of 5%. Now, how do we know the investor gets utility of 5%? Let's go back and look again at the utility function. And we notice that whenever your standard deviation is 0, all this to the right of the minus sign is 0. So for a risk-free investment, the level of utility is equal to the expected return because a risk-free investment has a standard deviation of 0. So if we have an investment with a standard deviation of 0 and the expected return is 5%, then the level of utility will be 5%. And that's what we are looking at right down here, okay? So here is an investment with a standard deviation of 0. Expected return is 5%, so we know the investor gets utility of 5%. Now, if they get a utility of 5% here, they are indifferent between all these points going up here. Every point on this curve with these diamonds on it must get the same level of utility, 5%. So Every point on here is giving the investor utility of 5%. Every point on this curve is giving investors a utility of 10%. And we know it's 10% because right down there on the y-intercept is an expected return of 10% with a standard deviation of 0. Up here, an expected return of 15% with a standard deviation of 0 gives an investor 15%. Now, this is not to say that there are 3 risk-free rates of return. There's only one risk-free rate of return, but this does not tell us what the risk-free rate of return is. It just tells us if there is a 5% risk-free rate of return, the investor gets a 5% utility out of it. If there is a 10% risk-free rate of return, the investor gets a 10% return. If there is a 15% risk-free rate of return, the investor gets 15% utility. And investors will always want higher levels of utility. So every point on this curve is preferred by our investor to every point on this curve, and every point on that curve is preferred to every point on this curve. Now, these are just 3 different curves. There are an infinite number of indifference curves, okay? So we just drawn 3 of them there, but there's another one that goes up here, another one that goes up there. They're all parallel to each other. And so for a particular investor, they're all going to have the same slope. That slope is determined by the investor's A, their coefficient of risk aversion. But you could take this point, for example, right here, take a look at its expected return, which is 40%. Its standard deviation, which looks like it's going to be about, I don't know, maybe like about 0.95, something like that, okay? And you plug it into the utility function, and you would get 5% is the level of utility. Every single point on this curve, you take the expected return, standard deviation, plug in an A of 0.75, you will get 5% as the level of utility. All the points on this middle curve, you plug them in, you'll get a utility of 10%. All the points on the top curve, they're going to get 15%. One more diagram we're going to take a look at, and obviously these were imported from Excel. This one is 3 different investors. The one with the squares has an A of 0.5. The one with the triangles has an A of 0.75. The one with the circles has an A of 1.0. So this one has a bigger A. They are more risk averse. The one with the squares, they are still risk averse, but they are less risk averse. So as we can see, this particular investor with the squares here, they are requiring, they are less risk averse. They are willing to take on standard deviation without requiring a lot of additional expected return. The one with the circles, they require more expected return for taking on some standard deviation. Every single point on these curves, okay, here with the circles, gives the investor a utility of 5%. Also, every single point on these with the triangles gives the utility gives the investor utility of 5%, and every single one of these with the squares also gives the investor utility of 5%. So, and we know that because for each of them right here, when you've got a standard deviation of 0, you get 5%. So if at this point the investor gets 5% and they are indifferent between all the points on the line, then every point on that line has got to give the investor the same level of utility. And you could plug the numbers in. They're going to be approximations because you can't tell exactly what the standard deviation is on these or the expected returns, but you're going to see that they're all going to give these 3 investors utility of 5%. So this is 3 different investors, okay, right here. Whereas when we scrolled up, okay, this one was 1 investor with 3 different indifference curves. So this, you can tell it's the same investor because all 3 curves are going to, all 3 of these curves have the same slope. This, you can tell, scrolling down, is 3 different investors because they all have 3 different slopes. When it's steeper slope, that means you are more risk averse. You have a higher A. When it's a shallower slope, you're still risk averse, but you are less risk averse. You still got a positive A, but it's going to be a smaller number. You are more willing to eat those Brussels sprouts, okay, for some Boston. You don't like the Brussels sprouts, but you know, you don't require as much Boston cream pie to eat a few of those Brussels sprouts. Okay, so that's it for this particular section right here. Next time we get together, we're going to be talking a little bit more about how we actually calculate the level of utility for an investment.